screen share. Just, is it visible now?
Yes, through it's visible.
Yes.
Okay. So as usual, we will start.
चार्ट बहुत रहे हो बाय
Please keep your mouse. Okay, so I will be calling out the please respond. Amir, Abhinav, Abhishek. Guys, am I audible?
Yes, yes. Yes.
Abhishek Kumar,
Yes.
Abhishek Kumar Verma,
Yes, present.
Aman Ahuja,
Yes.
Aman Nigam,
Yes.
Aman Nigam is there, right?
Yes.
Aniket Prakash Bhagat, Anurag Thakur, Avola, Ayush,
Yes.
Deepak, Harrison, Harsh,
Yes.
Himanshu, Joseph,
दीपक चौरसिया मार्क कर दो
yeah,
दीपक चौरसिया
okay,
ऊपर हाँ
Joseph, Isha.
Present.
Can you restate it?
Hello, Dhruv. Himanshu present.
Okay. Joseph, Ishan,
Ishan is present.
Keshav,
Present.
Khushi,
Yes, I'm present.
Kshitij, Manoj,
Present.
Adil,
Present.
Mohnish, Nandini,
Yeah, Nandini is present.
Pranay, Pranjal,
Present.
Prashant, Priyanshi, Rudransh,
present
Sanchit,
Yeah, present.
Shaurya,
नहीं लोगे
Amir, can you please shut your mic?
मम्मी कहीं से बोलते
Shaurya, Shivam,
present.
Shivanshu, Shoham, Srihari,
Present.
Shashi,
Present.
Smriti,
Present.
Sudhanshu, Tamil
Present.
Selvan,
Dhansu present.
okay, Tamil Selvam, Vishal,
Yes.
Yuvraj,
Present.
Anyone else?
Yes, Amir.
Yeah.
Yeah.
Dhruv, Anurag Thakur. Okay.
Kamal is present.
Who's present? Can you repeat?
Kamal Selvan.
Okay. Anyone else?
Yeah, Joseph.
Any more? Okay, so I guess we are done. If anyone is remaining, please DM. Okay, so last time we are working with this spreadsheet. Now we will complete it. So we have the KNN based model. So it has been a quite long. So I will give you a quite quick recap of it. So basically we are working on these two data sets, and let me run the cells also. Otherwise they will not work out. So basically we have tried to drop some of the columns, and then we have selected only these columns. Yeah. Okay, let me run. It is taking some time. So yeah, in the meantime, I will talk about this data set. So, okay, guys, it is taking some time. I will go to this still initializing. Just give me a second. I just change my link. Maybe. Guys, there is some issue with the kernel. Okay, let's give this some time. So what I am trying to say is we have basically selected these columns out of our data set, and then we have stored these columns in the movie, and then we try to get the words out of the weird format that is present in the dataset. So we make some function, and we define the convert keyword function, convert cast function, or convert clue function there, and then we apply them in the dataset. And with it, we are able to get the features out of the dataset. And then we are trying to replace the spaces with nothing, and then we make them in a single list. So that is what basically we have done in the last section. So now if this works, I will try to go ahead. Okay, so the kernel is initialized now. There is issue with some internet. Okay, so now we have it. Just give me a few more seconds so that I can run all the cells. Okay, so this is the shape column that we have, and then we merge them. So this is the info column, and then we basically try to get this out of this database. We drop the null values and we hope, yeah, there are no duplicates. So just the same. So that there is no issue, and then I don't know why it is here so here. Okay, so we are just there. We are just overview column, we shown us, and then we replace it as spaces. And there is the final data set that we have obtained. So we have the movie ID, we have the title, we have the genres out of that year format, we have the keywords, and we have the overview. And finally, we have the cast, in which we have selected only the 5 most significant actors, and then there is a crew, in which we have only selected the director, I guess. So we are making a new thing that is text. So in text, we are basically going to add all the columns together. So the overview, genre, keyword, and cast crew columns are now together. So if we try to see it now, okay, we just actually yeah. So these are the text that we have created, and now we are going to make a new data frame. That is, let's write it new movie. So we will basically have only the movie ID and the title and the text. Yeah. So if we see the new movie data frame now, we will get some. Yeah. So there are only text in this data set as we have combined all these columns together. So now we don't need that. We only need the text column to get the similarity between the two movies. So we focus on the text. Okay. So tag is basically the list. I guess I have displayed it in the previous session also. So this is basically the overview or the summary about the plot of the movie. And then this is the director, and these are the five actors that we have selected. So now what we will try to do is we will try to convert this into a string so that we are able to vectorize. So let me do that. So we are basically going to apply a lambda function. So what it is going to do is it will get the spaces and then join each of the. So what is to it basically takes an x, which is the list, and then append it by the spaces in between. Let me join this. Okay. Yeah. So if we now see our data frame, yeah. So now it's a list, and so now it's a string instead of a list. Previously it's a list, and now we have converted it into a string. So we can also verify it with the help of the count. I hope you are able to see these two small quote unquote signs here. So it basically try to say that it is now converted to a string. So now we will use a very simple technique called bag of words to convert this string into a vector of the number that our model will understand finally. And then we will use the KNN technique, which is basically sorting the vectors with the help of cosine similarity between them. And then we will apply the reverse sorting so that we get the highest similar vectors out of the all 4,000 something vectors here. So let me get the scikit-learn library. Okay. Like count vectorizer is the module that we basically use in the scikit-learn library to get the bag of words implementation. So we will basically create a object series. So it's the count vectorizer. And since we have almost 5,000 movies in our dataset, so we can limit the vocabulary to 5,000 words. I will be giving the theoretical interpretation about the bag of words in a while. I have a presentation on this, so just wait for it if you are not getting it right now. Okay. So we will limit the size of the vocabulary to 5,000, and then we will also remove the stop word. I hope everyone is familiar with stop word. So if you do not know what stop words are. So stop words basically mean the words that do not contribute to the meaning of the sentence, but they are used in the sentence for its formation. So they are basically the punctuations or isma or anything like that that is not very significant in the meaning of the word. So we are going to remove them by basically using the stop word thing here. And um, yeah, so it's in a feature extractor model, not in the extractor. Sorry for that. Guys. So next, we will create a thing called vector. Spelling mistake. Okay, so now it was formed. So now we will use this object CV to make a so we are basically trying to get the vectors out of these strings. So we will use the object called CV and then we will use CV.transform. So we want to transform the text column. We will convert it to a numpy array. Okay. So let me give you a look of the vector. Okay. So this is vectors is basically a sparse vector of size basically 5,000 or the vocabulary size that we have specified. And this is going to be a frequency vector. So there are very few words present in a particular movie text column. So most of the columns is zero here. So let us see what is the vocabulary that we have. So we will import this model. We will use the get features of yeah. Yeah. Okay. So this is a array of 5,000 words. So basically it contains some of the digits here like 00 and triple zero, triple double 007, 10, the 100. So these are the words that may be present in the word data. And then there are words like ability, able, abroad, abuse, excess, and other words. So they basically make our vocabulary. And for each of the words, the markings here, like the zero word. So 000 is not present in the first movie tech column. Like there is no 000 in this string. So it is marked as a Z. If there is something like in that is present here, so we are going to get a one there where the in is present. So this vector is basically a 1 cross 5,000 vector if there are 5,000. So I hope it's clear now. So one more thing I missed out there. So basically, if you find the words like abilities, ability, able, these are kind of very similar words. And we are considering them into different words in our vocabulary. So what we can do, we can install our natural language processing library. So it will help us to convert these words into a single word. So this process is basically called as stemming. Stemming basically refers to conversion of words into their root form. So we will be going to do that now. So we are here. Let me see. It's a natural language toolkit. And from it, we are going to import the stem. So it comes by the name of what a stemmer. That is not possible. Okay. Okay, I guess there is some issue here. So we are telling us to do something like this. Okay. Okay, so now we have the PH module here. So we will be going to define a stemming function for now. So it get a text as the argument. So text is just a string here. And then we will take a empty list. And then we run our. So I hope everyone is familiar with this text.list function. So basically it's a string. So we are using it to get each word out of the list. And then we can simply Very- So we are going to apply this. Not a time. Just wait for a second. Okay. So I hope you can see it now. So let me do one thing for the comparison. Okay. Okay. So as you can see, there is a verb called paraplegic here, but it gets converted to a paraplex. There is a word called marine that is converted to a marine. So they are basically the root words. So we want them to remove any kind of suffix or prefix that is present in the words. Like we have seen the ability, able. These are kind of similar words, but we are taking them individually in the account in our vocabulary. We don't want it. So we are basically using this function. So now we are going to store it in the same thing. Okay. So it will now get converted. Just a few minutes. Okay. So now we have this thing here. So this is basically a warning of replacing the current data set that we have. We are replacing the string with the new 10 string. So if we perform these steps again, we have to do this, and then we have to do this. So I hope you can see it now. Like this is a vector of 5,000 and it contains one ones in a while. Like this is very sparse vector. It contains ones where the word is present in the text string itself. Let me clear this output. So let us see our vocabulary again. So now if you are able to see, there is only word like able. So there is nothing like ability, able. Like these words are not repetitive in the vocabulary, so it is now containing more words and giving us more good vectorization. So guys, there is a very less time remaining, I guess 4 minutes. So if you want anything to ask me out right now, please feel free to ask it, or I will be sharing another link. So try to join. So is there anyone who want to ask anything that we have done or we have done in the previous section? there is any doubt in the stemming or if there is any doubt in the other thing. I hope we are good. Some more like that. So I'm basically using the metrics module of the SQL library to import the cosine similarity function. I hope everyone is familiar with the cosine similarity function. We have already read it in the basic math. So now we are going to find the similarity metric. So guys, this module will take some time to run. So I hope I am going to make this end this meet right now and going to send another link. So please try to join.